So very good morning to all. Today we are going to explain you about the uses of MAC and hash functions. So in the same topic called authentic requirement and authentic function. So we have already discussed the various kinds of attacks on the communication network. So now we are moving on to the message authentication code. What do you mean by message authentication code? So it involves the use of secret key to generate a small fixed size block of data. So which is said to be an cryptographic checksum, or it is otherwise called as MAC. So this cryptographic checksum or the MAC code that has been generated or a small fixed size of block data that has been generated will be appended along with the message. This appended form of data will help me to identify whether it is from the authorized user or not. So A and B share a common secret key K. Okay, so when A has a message to send to B, it calculates a MAC so as a function. So once the MAC function has been generated, that is a fixed size of block has been generated with the help of an shared secret key that is appended along with the message, and it has been sent in the transmission channel. So this is the usual procedure we used to do whenever we are talking about the authentication. So this diagram explains you about the basic uses of authentications. So what are the basic uses of authentications? The first thing is simple message authentication. So here the message that has been generated and a MAC code has been generated using the secret key. Okay, that is appended along with the message and sent in the transmission channel. So just we are generating the MAC code, that is nothing but a form of a code that has been generated purely based on the message which I am sending. So in the receiving end, the message appended along with the MAC code has been received. So the MAC code that has been received has been compared against in the receiving end by recalculating again the MAC code. When the calculated MAC code and the received MAC code is found to be same, it finds that it is from right person and the message has not been altered anywhere. This content modification, sequence modification or timing modification has not been occurred. Okay, so when these kinds of attacks happens, my message has been altered, my sequence has been altered, definitely whatever MAC code I generate in the receiving end will be different from the MAC code whatever I have received. Okay, so second thing is second diagram explains you about message authentication and confidentiality. So here the message that has been generated. First, a MAC code has been generated that is appended along with the message. Now, the appended message along with the MAC code has been entirely encrypted using another secret key. And after encrypting that, here I am taking care of confidentiality. I am also pretty sure, or I am also much concentrating on my signature or the MAC code that has been generated. So it has been sent in the communication channel. So now the receiving end, the decryption has been done. So after decryption, a message along with the MAC code that has been received. Okay, so now again recalculate the MAC code and compare against the received MAC code. So here I am also not only taking care of authentication of the identity of the user, I am also making sure whether my message is free from the third party, okay, by providing encryption. So the third thing is third diagram explains you about all these kinds of functionality. So before sending the message to the MAC generating function, there is a possibility of attack might be happen in between. So what I am doing is I am encrypting the entire message and then the ciphertext has been given as an input to my MAC code. What if my MAC code generator has been compromised? My message will be revealed to some other person, right? So in order to overcome that, what I am doing is I am encrypting the message. The encrypted form of message is given as an input to my MAC code generated. So for the encrypted form of message, that is for my ciphertext and MAC code has been generated and it has been appended along with the ciphertext. So ciphertext and its MAC code that has been sent in my communication channel. So the receiver has two works to do. One is to find out what is my actual message. After finding out my actual message, I have to find out what is the I have to find out whether it is from the right person or not by recalculating the MAC code. So that is what happens over here. So it is decrypting the message and retrieving back, and then ciphertext, for the received ciphertext, it is recalculating the MAC code and it's finding whether it is from the right person or not. So this is the three major uses of MAC code. So moving on to hash functions. So as a hash function says that it accepts the variable size messages M as input and produces fixed size output, referred to as hash code. So unlike a MAC, an hash code does not use a key but is the function only of the input message. So the hash code is also referred to as message digest or hash value. So what are the basic uses of hash functions? So this is the diagram that explains you the basic uses of hash functions. And hash code has been generated and then it has been appended along with the message, and then encryption has been done. So encrypted form of the hash code along with the message that has been sent in the communication channel. So since it has been encrypted, I have to decrypt it. Again, hash code has been generated. So here we are just replacing the MAC code along with the hash code. That is the only main difference we find out over here. Okay, so second diagram explains you about the same thing. So what I am doing is, hash code has been generated, the calculated hash code has been encrypted and then it has been appended. So with the receiving end, the receiver has to perform decryption of the hash code and it has to calculate the hash code for the message what has been received, and it has to be compared. And the third diagram, it says that here I am using a secret key, that is I am altering the size of the messages and then it has been, so there is a possibility of my message to be revealed by the hash code. So I am altering the size of the messages and then hash code has been generated and it has been appended along with the message. And then at the receiving end, the appended along signature, hash code has been generated for the appended form of message and then it has been compared. And the fourth diagram explains you about all these combinations. An S has been appended along with the message, hash code has been generated and it has been appended along with the message, and encryption along with the encryption has been done with the hash code and the message. After encryption, decryption has been done. Then decryption, I am getting the message and the H of M appended with S. So now I have to append the S at the receiving end to calculate the hash code, and comparison has been done. So these are the basic uses of hash code. Thank you.